Hello everyone, this is Alistair here, and today's problem of the day is titled Swap kth nodes from n's. So in this problem, you are given a linked list, and your job is to swap the kth node, which is given with the variable k, and you have to basically swap them. And you are also given a variable n, which is nothing but the size of the linked list. So here k is equal to 1, so we will be swapping the nodes with the data 1 and 4, and on doing that we get the resultant linked list to have the order 4, 2, 3 and 1. Now we could simply swap the data itself, but they have specifically asked us not to change the contents of the node but to swap the nodes itself. So let's have a look as to how we'll be doing it. So let's consider an example wherein we have 5 elements 1, 2, 3, 4 and 5. So n here in this case is 5, and let's say our k is 1. So first off, there will be three cases which will we have to consider separately. First case is where k is the beginning node, because in that case we would have to uh, handle the cases separately, since the previous of beginning is null, and also, well, not null, there's no node behind the head node, and there's a null pointer after the last node. So for that case, we'll have to handle that case separately when k is equal to 1. And similarly for k equals to num, meaning the nth node from the beginning, which is nothing but 5, and the nth node from the end, which is nothing but 1. This is similar to the case of k equal to 1. So we'll have to address them separately. And the other case would be when our k is, let's say, less than n, but greater than 1. So we'll have to handle this case separately as well. So let's have a look at the separate cases one by one. So let's say we'll first start with k equal to 1. So for k equal to 1, what we'll do is we'll maintain a pointer. Let's call it first pointer, which will point to the beginning node, kth beginning node, and we'll have a second pointer which points to the kth end node. And similarly, to maintain the previous nodes, we'll have fp, that is the first previous, and sp, that is the second previous. Since first here is already pointing to the uh, first node, that is at k equal to 1, we need not move it. But second here is not pointing to the first node from the end, that is at 5. So for that, we'll move the s node n minus k times, which is nothing but 5 minus 1, that is 4 times. So on moving s 4 times, we move from 2, then 3, then 4, and then finally each 5, that is, we move the s 4 times. And simultaneously, whilst moving s, will keep on updating a s previous to be the previous element of s. Now after doing this, we have to basically swap them, right? So before swapping, we have to also consider the previous elements of the nodes to be swapped, so that we don't like disturb the linked list. So for that, what I'll do is I'll consider the previous element of the end node. I'll mark its next pointer. I'll mark its next node to be, since 4 here will be pointing to 1 on modification, I'll mark its next to be f. Now that is done. Now we have to consider this s node. So for s, the next node would be the next node of the first node. So we'll do that, the next node of first node. On doing this, we have to now handle the first node. So what we'll do is, since first node is going to be our last node, and this sp is already attached to 1 in this case, in this statement, what I'll do is I'll simply mark the next node of first to be null. So in this way, I'll be able to handle the swapping of nodes when k equals to 1. Now let's say my k is not 1 but n. So let me erase this first. Yeah. So let's say my k is n, that is 5 here, and we have our first initialized to the head and also the second initialized to head, fp at null, sp at null. Now when k equals to num, meaning I have to move the first pointer to the kth position, that is 5. It simply means that I have to move f k minus 1 times, that is 4 times. So on moving f 4 times, I'll get f4 here, then at 3, then at 4, and then at 5. So my f will reach at 5, and simultaneously we'll keep on updating our fp to be the previous of f, which is nothing but 4 here. Now similarly, like previous example, we weren't moving f because it was already pointing to n. Similarly here, we will not move s because it is already pointing to the nth node, which is fifth node from the end, that is 1, 2, 3, 4, 5. So s is already here, meaning we will be moving s n minus k times, that is 0 times. So after getting our s and f fixed, we simply have to swap them whilst maintaining the previous node. So for that, what I'll do is I'll consider the first previous. I'll mark its next to be my second. I'll take the first node, and I'll mark its next to be the next node of s. That would be s of next. And after this, I simply have to maintain the order for s. So I'll mark the next node of s to be null. And on doing this, my linked list would result in 5, 2, 3, 4, and 1. Now let's say my k is somewhere in between. Let's say, yeah. So let's say my k is less than n. Let it be at 2, for example. So in that case, my f would be initialized here, s would be here, fp would be null, sp would be null. So I have to maintain this f at the second position, that is at 2, right? So I'll be moving f k minus 1 time, which is nothing but 1 time. That is 2 minus 1, which is nothing but 1 time. So I'll move my f once. So my f will be pointing to 2, and similarly simultaneously I'll move my fp to be previous of f. So on doing that, also I have to maintain the position for the second node, that is the kth node from the end. So for that, I'll move s n minus k times, that is 5 minus 2, that is 3 times. So on moving s 3 times, I'll be moving it to 2, then 3, then 4. And I'll have my previous node to be at 3. Now I have to maintain the order and swap the nodes as well. So for that, what I'll do is I'll simply use the first previous, mark its next node to be equal to second. So my 1 would be pointing to 4. Now I'll take in the second previous, mark its next node to be equal to first. So my 3 would be pointing to 2. Now after doing this, since the first and the third node are handled, we have to handle the f and the s node. Now to handle the s node, f node, I have to change the next pointer of f to be equal to the next pointer of s. So let's say I did that, f of next to be equal to seconds next. After doing that, I'll have 2 pointing to 5. Yeah, 2 pointing to 5. And after doing this, I'll have to maintain this second node as well, right? I have to somehow point this s to the next node of f, that is 3. So that would be s of next to be equal to f of next. But we cannot do this because we have already modified our f dot next. So in order to handle that, what I'll do is I'll simply create another node, let's say temp, and I'll store the next of first first kth node, that is the node at 2. So I'll be storing 3 in temp, and I'll use that temp to point to the to use that temp for the next variable of next node of s. So on doing this, we'll be able to swap the nodes with wherein our k is less than n, and maintain the order of the linked list without breaking it. So after swapping, the resultant linked list would be 1, 4, 3, 2, and 5. So let's jump right onto the code. So first, we are also given a condition wherein a k could be greater than 5. In that case, there will not be any node that we can swap, meaning this condition would be invalid, and they have asked us to return the head node as it is. So for that, I'll make a check if my k is greater than none, and if that is the case, then I'll simply return head as it is. Now we'll create a node first. Let's call it first, and we'll initialize it to head. Similarly, we'll create another node second, initialize it to head. We'll create another node temp for our special case that wherein our k is less than n, and also we'll create two more nodes, that is the first previous and the second previous. So let's call it first prev, which would be null initially, and the next node that we'll be creating is sprev, that is second previous, which would be also null. So we have to maintain our first node, basically to point it to the kth node at the beginning. So for that, I'll iterate over the linked list. Since we are already given the number of nodes, I'll use that, and I'll iterate till for the first node, I'll iterate it till k minus 1. And I'll have my first previous to be first, and then I'll update my first node to have first dot next. After doing this, I also have to move the second node to the correct position. So for that, I'll move it till n minus k times, that is num minus k times. In that case, my s previous would be second, and my second would be seconds next. So after moving this, we have to simply swap the nodes, but there were three conditions as we discussed. So the first condition would be wherein our k equals to 1. So in that case, we'll use the second previous, have its next point to first, and we'll have the second node and have its next point to first next, and we'll simply have the first next pointer to be equal to null, meaning our first node will become the end of the linked list. That's why we have to point it to null. And after doing this, we'll simply return second as it is, since second would become our head. Now there's another case wherein our if our k is equals to n. So if that is the case, then we'll simply do the similar operation, but we'll be using f previous in place of second previous. So f previous dot next would be second, and first next would be second next, and our second's next value would be null, and we'll simply return first. Now to handle the case wherein our k is less than num, So for that, let's just simply put it in an else block. And first off, we'll handle the first previous. We'll mark its next to be equal to second. We'll take in the second previous, mark its next to be first. Then we'll use the temp that we created to store the next node of the first kth node. And after doing this, we'll simply swap the first and second. So first of next would be equal to seconds next, and seconds next would be equal to temp. After doing this, we'll simply return the head, and I guess we are done. Let's try and compile. Oh, all right. It should be I plus plus, yeah. All right. So that was it for today's video. If you have any doubts, you can ask them in the comment section. And thank you for watching.